we got two lines that never intersect. That's what we have here. Now, do you see these little arrows right here?
Yeah.
I use those to say these are parallel without me actually saying the two lines are parallel. So you're looking for arrows. So arrows are used to indicate lines are in fact parallel. If there's a picture with multiple parallel lines that are going in different directions, you might see, you remember like tick marks? I could put 2 tick marks, 3 tick marks, 4 tick marks. You can put 2 arrows, 3 arrows, 4 arrows. We usually don't have that many parallel lines, but if you see 2 arrows, you're looking out for 2 arrows again to see which line is parallel to it. Symbolic notation. If I want to say these 2 lines are parallel without using the word parallel, the first thing we're going to do is we're going to note that I have 2 lines. So I have line AB, and I have line CD. Notice I'm putting a space between them because we are going to put a symbol between there. I want to say they're parallel. You know what's good about geometry? A lot of times what we want, we just draw a picture of it, right? If I want lines, I put lines above it. If I want to say things are parallel, I just put a little parallel symbol between them. Notice they're kind of angled. They're not straight up and down. They're a little bit angled. If you draw them straight up and down, I think we'll be able to figure it out, right? But traditionally, they're a little bit angled. All right, so now we rehashed what parallel lines are. Isaac, do you mind picking up your head, please? Thank you very much. All right, but like Jared said, everything we did before is the crux of this one. We're just adding something to it. So our last lesson was we have a transversal with lines that aren't parallel. Today we have lines with parallel. If you have parallel lines, all these rules apply. If they're parallel. If not, we can't use these rules. So if I have parallel lines and I find corresponding angles, those corresponding angles are going to be congruent. They're going to be the exact same size. So if I have 2 corresponding angles and one's 60, the other one must also be 60. Yeah, I wouldn't write on those just yet, the pink sheets. We'll actually go through each one, what kind of examples we can do. The examples will be nice because I can actually put what a corresponding angle is on there. All right, so corresponding angles are in fact congruent. Alternate interior angles, that's what we did for bell work. Those are the ones that are on opposite sides of the interior. Those are going to be congruent. Hey, if alternate interior angles are congruent, alternate exterior angles are also congruent. Wouldn't it be nice if they're just all congruent? We just don't have to memorize this stuff. But we do have different ones. Same side. When you read same side, whether it's interior or exterior, those are going to be supplementary. Those are going to be supplementary. So we either have congruent or we have supplementary. And supplementary. These are all the new ones we learned. Then we rehashed vertical angles. Reminder what vertical angles are. Those are those angles that are directly across from each other. So if you have like an X, the ones that are top or left, vertical angles are always congruent. And finally, our linear pair. Remember, your linear pair was the one that makes a straight line. What's the degree measure of a straight line?
180.
180. So if you have linear pairs, they're not congruent. They are supplementary because they add to 180. The only way that a linear pair can be congruent if they're both 90. 90 and 90, but they are supplementary. All right, I don't know how you want to memorize this stuff. I mean, we have a pink sheet. Sometimes it's nice to just kind of know it without having to look at our pink sheet every single time. But I just remember, hey, same side is different. Same side is our supplementary. Same side, supplementary. Everything basically else is congruent. I mean, we have linear pair, but that makes a straight line. We should just be able to figure that out. But same side's the only one that are supplementary. Everything else is just basically congruent. So if you have a 50-50 shot and you don't know what your answer is, you might as well pick congruent because it looks like congruent happens a little bit more than supplementary. All right, so if you just have to take a guess, congruent would be the way I lean. Okay, let's see what this looks like. All right, it says identify the angle pair as congruent or supplementary and give your reasoning. So it's comparing 3 and 5. 3 and 5. Are they supplementary or are they congruent? Yeah, they are congruent. Why? What type of angles are 3 and 5? Are they on the same side of the transversal or on different sides? They're on alternate, right? So they're alternate. Are they interior or exterior? So they're alternate interior angles. What does it say about alternate interior angles on our sheet? They are congruent. So 3 and 5 should be congruent. And the reason for that, it says give your reason. Well, that would be the alternate interior angle. Now, if you look at your pink sheet, what does it say after the alternate interior angle? Does it say theorem, postulate, definition? It says theorem. Yeah, it's not hard to read a pink sheet, right? It says theorem, so I do want to put theorem down. It is important that we put theorem. What was it? Yeah, I'm going to say it's congruent. It's alternate interior angle theorem. And why I have to put theorem? Go with me down this path, okay? We know they're alternate interior angles. But the theorem indicates, oh, we have parallel lines, so they're congruent. Just saying something is an alternate interior angle doesn't mean anything. It just means, like, I know they're on opposite sides. And as soon as you put theorem, it says, oh, they're parallel lines, so they are congruent. So when I justify something, we use a theorem or a postulate. Our postulate will be our corresponding angle postulate. All right, so let's look at 1 and 8. 1 and 8, I got here and here. Are they on the same side of the transversal or different side of the transversal? They're same side. What does same side tell us it's going to be? Supplementary. We should know it's same side exterior, right? I'd actually be okay if you put same side theorem. Same side angle theorem. I'm not going to take any points off for it, but we should know it's exterior. So we know that these are going to be supplementary. And we use same side exterior angle, and that once again is a theorem. It says it on your sheet. If you forgot, you just look at it. It says right after it, it's a theorem. We'll do one more together. We'll do 2 and 6. 2 is here, 6 is here. Don't shout out any answers. We got a 50-50 shot, okay? Who thinks 2 and 6 are congruent? Who thinks 2 and 6 are supplementary? Who didn't answer? Okay, let's go into a camp. Hey, 50-50 shot, right? We got 2 and 6. Are they congruent? Raise your hand if you think they're congruent. Oh, we got more people this time. Who thinks it's supplementary? Okay, let's look at these. If these were same side interior, I'd agree with it, but 3 and 6 are same side interior, right? 2 and 7 would be same side exterior. Are these same side angles? I mean, they are on the same side, but 2 and 6 are corresponding because they're not both on the interior, they're not both on the exterior. Top right, they are corresponding angles. What do we know about corresponding angles on our pink sheet? They are congruent, so we should put congruent on that one. And that's actually the corresponding angle postulate. So we need to put P-O-S-T or postulate. Important that we put postulate there. So, what did we learn from that one? Just because they're on the same side doesn't mean that they are supplementary. It has to be either they're both on the interior or both on the exterior. If one's on the interior, one's on the exterior, then we're looking for corresponding angles. That's where we can get switched up with the same side. Just because they're the same side doesn't mean they're supplementary. Because these aren't same side interior or exterior, these are corresponding. Do we see those corresponding angles now? Okay. Give it a shot. D, E, F, G, H. I'll give you a couple minutes, then we'll go through it together. When I saw 1 and 7, 1 and 7, well, those are alternate exterior angles. Alternate exterior angles better be congruent. So that one we should have had congruent. And we should have alternate exterior angles theorem. When I look at 4 and 5, 4 and 5, those are same side interior. They're not corresponding. Corresponding would be something like 4 and 8 or 5 and 1. They're not corresponding. They're same side interior. Same side interior angles are supplementary. So 4 and 5 should have been supplementary. We use same side interior angle theorem. 3 and 7. 3 and 7 are corresponding angles in the same location, bottom right, bottom right. Corresponding angles are, in fact, congruent. So we're going to put congruent. I'm going to save myself time by putting the congruent symbol. They were corresponding angles. The corresponding angle happens to be a postulate. 5 and 6. 5 and 6, we're going to note that those have nothing to do with the parallel lines. That those are all contained in those 4 angles there. That means they're either a linear pair or they are vertical angles. Those need to be a linear pair. We should have said they're a linear pair, and a linear pair are supplementary because this equals 180 degrees. So those would be supplementary, and they will be a linear pair. And our final one would be 2 and 4. 2 and 4, once again, are contained within those 4 angles. It has nothing to do with the other parallel line. That means it's either a linear pair of vertical angles. Well, they're directly across from each other, so they are vertical angles, which means they are, in fact, congruent. And we use kind of like that vertical angle theorem. Vertical angle theorem. For the linear pair, you can use the postulate or the theorem. They both say they need to be supplementary. So this could be postulate or theorem. I would just stick with the theorem. That way you just have one postulate that's your corresponding angle postulate. They have to worry about being a postulate. Questions on any of those? All right, it might look completely different, but example 2 is pretty much the exact same idea. If you look at example number 2, I think we have another example down here. Example number 2, they give you an angle measure, 1 being 65 degrees. Now, here's my advice for you. You don't have to do it in this order. In fact, I wouldn't do it in this order. What I would honestly do is I'd find all of the angles that are also 65 degrees, because we know we have a bunch of angles that are congruent, right? And I'm also going to note that the reasoning you put here is going to be different depending on how you do this problem. So for example, if this is 65, what's angle 3 then?
65.
65 degrees. Why is it 65 degrees? Because it's across. What kind of angles are those? Vertical angles. So I can go number 3 is 65 degrees. And give my reason, I use vertical angles, or vertical angle theorem. Now, here's where we might be different. Okay, yeah?
Do we have to do the same thing? Like put congruent
We don't have to put congruent. No, we just have to say it's, because 65 means it was the same measure, right? We just have to put our measures and the reasons why I think. It's basically the same idea, except I'm not putting congruent or supplementary. I'm actually giving what value comes out. If 3 is 65, does anyone see another one that's also 65? Or looking at 65 here, does it? 5? Do you agree that 5 is 65 degrees? Okay, so let's talk about 5 being 65. I agree with it. Can we all look up here real quick? Because this is where our reasons might be different. Some of you might have gone, oh, those are corresponding angles. Some of you might have gone, those are alternate interior angles. Both get you to that being 65 degrees. So either you use this 65 and say they're corresponding angles, or use this one and use alternate interior angles. My advice is pick the one that you use to get to the 65. I might have used alternate interior angles since I already had 3, so maybe for myself I might put 5 because I used alternate interior angle theorem, but maybe you use corresponding. Does anyone see another one that would be 65 degrees? 7? How'd you get to 7? Use vertical angles. Could you have got to 7 by using corresponding angles with 3? Could you have used alternate exterior angles? Yeah. So your reason is a little less important than your answer being 65 degrees. I'm going to go vertical angles because that's what I would have used. 8 is supplementary. Why is 8 supplementary? Same side exterior. Okay, if it's supplementary, what's its measure then? 180? Well, that's what it sums to. We have to do 180 minus 65. That will get you 115. So this is 115. So 8, I heard 115. You use same side exterior. Could I have used linear pair? Couldn't I have said, hey, I'll put it in purple, like these equal 180 degrees? So I could have used a linear pair there. You saw same side exterior. Does it matter which one I pick? No. Just make sure you have something that backs up your thought. So you write down what you wanted to write down there, okay? I'm not going to write anything for the rest of these. You put your reason how you got there. Does anyone see another 115? You're saying 6. Why? What reason could we could put same side interior? Does anyone else see another reason I could put 115 for 6? Yeah, Belinda. We could say they're vertical angles. Perfect. Anyone see another 115? 4? Why? Alternate interior angles. So I have 4 as 115. Isaac used alternate interior angles. You could have also used corresponding angles with that angle 8 down here. He used alternate interior. Yep, that's what he used. So he said 6 and 4 are both 115 because they're alternate interior. And that's going to get me to 2 as well, right? I can use vertical angles to get to 2. So basically the rest are 115, right? And you put your reason down. What I'd like you to do is I would like you to do the next problem. The next one has 142. Go. Yep. Because you've been participating. I think you get what's going on. So we're doing this one. The difference is I give you a different angle. We still have our pair all of these real quick. We should have said measure of angle 1. Hang on, let's go through this. I'm not going to put any of my reasons down. That's up for you, okay? I would have gone angle 1 is also 142. I would have used vertical angles. So 1 should have been 142. Then we could have used corresponding angles to get to 3. We could also use alternate interior angles to say 3 is 142 as well. So 3 is 142. And then I can get to 8 being 142. I could either use the vertical angles. I could use corresponding angles. I could use alternate exterior angles to get to this one being 142 as well. Lots of ways we can get to 142. All right, I'm done with things that are congruent. Now I could use a linear pair to say these are supplementary. I could use same side exterior to say this is supplementary. I could do same side interior to say these are supplementary, or these are supplementary. So really 5, 2, 7, and 8, 4 are all supplementary. They're all supplementary in some form or fashion, so we need to figure out what supplementary means to this equation. Well, supplementary for these must mean that it's 180 minus the 142, which should have came up to 38 degrees. So is that my 5? 38 degrees. We could use vertical angles to get to 2 being 38 degrees. We could use alternate interior angles to get to 7 being 38 degrees. And I might use vertical angles to get to 4 being 38 degrees. Once again, your reasonings might vary, but your numbers better be the exact same as mine. I'll be honest, on the quiz, I'm going to be mostly just grading these numbers. You'll put your reason down. I'm just going to make sure you're picking, like, you're not making stuff up. But I'm going to have a hard time to know if you picked that reason. Obviously, if you said something is supplementary, and I never had a supplementary one up there, then we could maybe lose, like you never use a linear pair, you never use same side or something like that. That would be a problem. But really, just did your numbers match my numbers? That's your question right now. Do your numbers match my numbers? All right, we're going to skip example 4 real quick. We're going to go to 5, because 5 is something that you can do. But I want to go over how we're going to do this one. All right, notice how I put the numbers very small over here so we have more room to put our numbers down. So we're going to find number 7 and put a 38 degrees there. Let's just stop with writing the 38 degrees. Notice we don't have to put any reasons down. Look at your numbers over here. Does anyone see another number that would be 38 degrees? 5? 5, because we have vertical angles. Okay, 5 is 38 degrees. So 5 is 38 degrees. We use vertical angles, but it didn't ask for vertical angles. Does anyone see another number that would be 38 degrees?
13.
Which one?
13.
13. I agree with that. I'm going to pause there. I agree with it 100%. I want to talk about something real quick. So he said 13, so 13's here. Do you agree that these are corresponding angles?
Yes.
Same location, top left, top left. Okay, so 13 is 38. I'm going to write it down over here in my thing. 13 is 38 degrees. Yeah.
14 is what?
Yeah, let's not get there. I'm going to pause right here. I'm going to pause right here, okay? We're pausing right here with 13 being 38. Do we all agree that 13 is 38?
Yes.
Now remember, for 13 to be 38, I must have used parallel lines, right? Did we use both parallel lines? Yeah, because this transversal connects 2 parallel lines. Can we pay attention real quick? This is important for this problem. Can someone tell me why this one is not 38 degrees? I'll put it in red, actually, because that is not correct. There's a line, shouldn't it? That's a transversal. Is it on the opposite side of the transversal?
I'm talking about it's not the parallel line.
It's not the parallel lines. But do we agree these are alternate interior angles? Are those alternate interior angles? Now, yes, alternate interior angles, awesome, love it. We cannot use the theorem here, though. The theorem says you must be using the parallel lines. Look at what I used. I used this transversal, which connects these 2 lines which aren't parallel. I did not use the parallel lines, so I cannot use alternate interior angles. So we can actually not get up here. I can't get up here. That's why, do you notice how it says measure of angle 10 is 102? That's how we get up there where you're like, oh, this one's 102. Okay, this one's 102. So I'm going to use this 102 up here. I'm going to use the 38 strictly down here. So you got to be careful when you go from one line to the other. You better be going from one parallel to the other parallel. Otherwise, we don't know if they're congruent or not. Why don't we try the rest of them? Okay, give it a shot. Ask questions. Ask questions. I don't need reasoning. We just need to have the correct numbers. All right, let's take a quick peek at this. I'm just going to put it on my drawing, so make sure your drawing matches mine. I would have gone from 38 to 38 over here. Now, as a reminder, the 38s cannot go up onto this other rung. Like, this is not 38, I said, because we don't have the two parallel lines. I'm using two non-parallel lines, so that doesn't work. So that means I'm going to stay in this bottom zone, and I'm going to figure out the rest of these. Now, the rest of them must be supplements. Like if I look at this 38 and the angle above it, that's a linear pair. That's 180 degrees. So I'll just take 180 degrees, subtract 38 from it, and figure out that this is 142 degrees. So do you have a couple we need to change? That's okay. Let's change them. Let's change them. Let's just put them on our drawing. Let's get them on our drawing, and then we'll go back and we'll fix our letters, okay? So if this is 142, that means with vertical angles, this is also 142. Alternate interior angles, this would be 142. Vertical angles, this is 142. Once again, you might not have used my thought process. You might have used like alternate exterior 142, alternate interior 142. Just curious, what numbers did you guys put in all those? 102, okay. So I'm guessing you took the 102 from up here, right? And you probably used corresponding angles to put it here. But we can't do that. I'll put it in red. And reminder why we can't do this. So I'm guessing you put the 102 from up there to here. We use corresponding angles. But remember, you use two non-parallel lines to do that. It has to be using the two parallel lines. Is that kind of clear why it's not 102? Olivia, are you okay with that not being 142? I mean, is 142 not 102? No, are you? Does it make sense why it's 142 and not 102? Okay. All right, so the 102 stays up here. We should have came up with these angles also being 102. All of the rest of the angles should have been supplementary to that 102, which should have been 78. So the rest should be 78 degrees. Did we pick the wrong one for that one too? Okay, so all of those should be 78. Let's make sure our drawing matches mine, and then we can go back and fill in our letters. So we're going to be very, very careful, right? If we have a shape that looks like this and we only have two parallel lines, we have to understand that a parallel line goes to a parallel line, but you can't go from a non-parallel to a non-parallel. It's important for you to understand which ones are parallel. I'll leave it up there for a second. Let me know when you guys are done. Tom, I'm going to go through 4 with you guys. Now, remember, we only have 2 pairs of parallel lines. Those are my parallel lines. So when I write 12 being 102, or 121, sorry. It says 121 because they said 12 was 121, so I found 12, I'm pretty sure, and I put 121 there. Now, notice which lines I highlighted, right? That means you cannot put this one as 121. This does not work. I agree they're corresponding angles, but did I use the parallel lines? No. I didn't use the parallel lines. So that's why we can't take the 121 and put it over there. However, I'm just going to put it in the drawing, okay, guys? I do know that this is 121. I know for a fact that one's 121. And then what I could do is I could stay there for a second. Let's just stay there for a second, okay? Let's stay in this quad, these 4. Because we need to start understanding if I know one of these, we know all 4 of those. Because our vertical angles are congruent. And what do we know about our linear pairs? Supplementary. So If both of these are 121, these are going to be their counter ones. These are going to be our supplements to this one. So we're going to take 180 and we're going to subtract 121 from it. That's what we're going to put right here. We're going to do our 180 minus our 121, which should be what, 59 degrees? And we'll go 59 degrees. So if you know one of the angles, I highly suggest you just finish those quads. You're just like, I'm going to get the rest of those down. Okay? Now, we got to be careful here. Okay, I'll get it.
I didn't know if it was actually an option. I thought someone was just. Yeah, that was like over there.
Okay, we got to pay attention to this next part, okay? Can we look up here with me?
Yes.
Do you see this 121 here? Now, if I was going to use alternate interior angles, which I'm actually not going to use yet, okay? Guys, this is really important. Isaac. If I want to use that, I have to use this transversal here. Which means the alternate interior angle to 121 is actually this entire angle. So it'd be angle plus angle equals 121, which really doesn't help me because I don't have the other two angles. So I'm going to skip doing that. Instead, I'm going to go, well, let's move this 59 up here. Because this angle and this angle are alternate interior angles. So that works. And then I might go, do you see this vertical angle with that 59 degrees? Do you see that straight across? Yeah. So I'm going to go ahead and put that one as 59 degrees. And maybe now I pause. Because I can't do the alternate interior angles. I'm also going to note if I want to use corresponding angles with that green one, that would be this entire angle here too. So I don't want to write that one in because it'd be the entire thing. So now I'll go back to the drawing board and say, did they give me another angle? They gave me 6 is 75. So let's find 6. 6 is here. So we'll put 75 right there. Let's change our color because now we're on 75s. Now it might be a good idea to shoot that straight across with my vertical angle. Write my 75 degrees up here. I'm also going to quickly note that we do have alternate interior angles, which can get my 75 right here. I could use corresponding angles to put my 75 here, or vertical angles to get 75 here. How do I find the rest of these kind of quads? Because we have 4 angles here. I have the 75 and 75. How do I find the 2 missing ones? Yeah. Perfect. 180 minus 75. We have 2 verticals and we have 2 supplementaries. So if I want this angle right here, we better be doing 180 minus 75, which gives me 105. So everything was just alternate interior angles, vertical angles, linear pairs. This one has 1 twist in it. I still have to find these 2 missing angles. And the way you're going to find those 2 missing angles in this example is, what's the degree measure of a straight line? So to get from here to here is 180 degrees, right? So this angle plus this angle plus this angle equals 180. Do we know 2 of the 3 angles? Yes, so we're just going to start at 180, subtract 59, and then subtract 75, and that should give us this missing angle here. So that missing angle right here should be our 180 minus 59 minus the 75. That's where I might take out a calculator. What'd you get? 36. Which means the one straight across from it is also 36 degrees. Okay, so that one had a small twist in it, right? All right, then we have one more thing we need to accomplish today. We're not going to go through all of these. Before we begin, let me talk about Thursday. I'm sorry, Friday. We have class Friday, right? This lesson's running a little long, right? So what we're going to do is on Friday, we're supposed to have a quiz and a new lesson. What we're going to do on Friday instead is, it sounds like some of us are stressed out. We'll just take a pause on Friday. Friday will be a day to kind of finish homeworks. But we still have to try this before class, okay? Can we promise me we're going to try this homework? We're not going to stay awake till 2 in the morning finishing it. We're just going to give it an honest effort the next 2 days to see how far we can get. Because we're not going to take the entire day to work on homework. What it's basically going to be is maybe I'll do like half the day we can just work, and the other half will be like a review assignment. So if we're pushing off our homeworks, we're going to have just a ton of homework over the weekend, okay? Because I do want to point out the fact that Monday is not a normal Monday, it's a blue day. So everything is signed. No, we're going to still finish this lesson. I got a little bit more to do. That's why I feel okay that we're going to finish some stuff, okay? So, next Friday we don't have school. All right, guys, are we paying attention to what I'm saying?
Yes.
So if you decide to do nothing, because I'm going to give you part of the day on Friday, you're going to have 3 homeworks due on Monday. And if you think you're stressed out now, imagine having 3 math homeworks that you have to finish all by Monday. So let's work our best at getting as much of this done as we can. And to do that, I'd have to go through a couple examples, okay? So I'm going to do a couple of these. We won't go through all of them. But the idea behind these are pretty simple. You will have to set up an equation to solve for our x variables. And this is how we're going to do this. They tell me that L and M are parallel, right? So these are all parallel. In every one of these examples, we have parallel lines. Look at the angles they gave you. What kind of angles are those? What kind of angles are my 2 green ones that I have highlighted here? What type of angles? Are they same side interior, same side? They are corresponding angles. So we're going to put down here that I have corresponding angles. What do we know about corresponding angles? Are they congruent or supplementary? They're congruent. Since they're congruent, this is how we're going to solve for them. We're going to say 58 is equal to 5x minus 2. So if they're congruent, they're equal to each other. So I'm just going to slap an equal sign between them. I'm going to say that this 58 must equal that 5x minus 2. Then I just need to solve for x. That's just a little bit of algebra where I add 2 to both sides. I have 60 equals 5x. 5 is attached by multiplication, so I will divide by 5. That will cancel out my 5, but leave my x. And then I'll have 12 equals x. That's it. We just have to figure out, are they equal to each other or are they supplementary to each other? What was that?
That's all we have to do.
That's all you have to do. But then let's look at number 4 together, okay? Number 4 is where things are a little bit different. What kind of angles are my 2 green dots? They're same side interior. Do you agree with that? We just had one person tell me that. Do you agree they're same side interior? Are they on the same side of the transversal?
Yes.
Are they both on the interior?
Yes.
So we'd have to agree with same side interior. Are same side interior angles congruent or are they supplementary? They're supplementary. So if I put my same side interior angles, we'll remember that they're supplementary. They have to equal 180. So we don't just slap an equal sign between them. We have to add them and say they equal to 180. So notice this one we just slapped an equal sign between the two things. This one we're actually going to put, that means it's 9x plus 2, not equal to 133, but plus 133 equals 180. Now, if we're okay in algebra, this is going to be a pretty simple problem. We just have to maybe simplify this side. So we should have 9x plus 135 equals 180. Let's subtract 135 from both sides, because we always do our addition and subtraction first. So that's going to be 9x equals, what, 45? Divide both sides by 9. And we should have x equals 5. So let's be clear on these problems. You have two options. Either you slap an equal sign between the two things, or you say both of them add up to 180. And then we solve for x. The only times you get really, well, first of all, you get really complicated if you don't know what any of the angles mean. That won't be, but it's part of your homework, okay? I just want to show you where it gets a little bit more tricky, and that's this type of problem. Now I have two variables, right? I have x's and I have y's. Here's my advice to how you're going to solve this one. Two of them will be the same variable. The third one will be a different variable. So the very first thing you're going to do is you're going to locate the one that has the same variable, x and x. So I'm going to pretend this is the entire problem right now. I'm going to forget about the y for a second. I'm just going to say to myself, wait, aren't these alternate interior angles? Does that make sense? Alternate interior angles? Are they on opposite sides of the transversal? They're in the interior. Okay, alternate interior angles. Alternate interior angles are supplementary, or are they congruent? They're congruent. So because alternate interior angles are congruent, I'm going to set this up as just being 8x minus 31 equals 6x plus 3. A little bit more difficult algebra because I do have variables on both sides. But remember, the idea is still the same. I want all the x's on one side. I want all of the numbers on the other side. So I'm going to go ahead and I'm going to subtract 6x from both sides. And that'll give me 8x minus 6x, which gives me 2x minus 31 equals, well, 6x cancels out, and I have plus 3. Then I'm going to add my 31 to both sides, giving myself 2x equals, looks like 34. Divide both sides by 2, and I'll have x equals 17. And then we would insert this into however we want to solve for y, okay? Now, we have to understand that y has to do with one of these two. So I'll change my color real quick. I'll change it to maybe purple. Blue, sorry. All right, what do we know about these two? What kind are these two?
Same side interior.
Same side. No, these aren't same side interior. I think these are linear pair.
Yeah.
And what do we know about linear pair? Are they equal or are they supplementary? They're supplementary. But what about these two? Now these are same side interior. I think those are the ones you're looking at. What do we know about same side interior? Supplementary. So I'm just going to pick one of those pairs and say they equal 180. I'm just going to leave this one up here, okay? So I'll go, okay, that means 5y plus 35 plus that 6x plus that 3 equals 180. But don't we know what x equals?
Yes.
We know it equals 17. So we're actually going to take that 17 and we're going to go ahead and plug that in here. So now, yep, we're going to have 5y plus 35 plus 6 times 17. That's where we take out our calculator. What's 6 times 17? $60 plus 48. What was that? Not quite. 102. No, way off. Wait. I think I did it wrong. Yeah, it is 102. Way off by being correct. So we now have 102 plus 3 equals 180. Let's simplify by combining all of that stuff. So 5y plus 35 plus 102 would be 137 plus 3. What do we got? 140 equals 180. Subtract 140 on both sides. 5y equals 40. Divide both sides by 5, and you have y equals 8. So, yeah, they're not the easiest problems in the world. I'm not going to lie to you. But really the hard part is the algebra, right? Or can be. Guys, what kind of class are we in? Are we in algebra or are we in geometry? We're in geometry. Most of your points are these two equations. All right, so if you don't know the algebra behind it, at least set up your two equations. Just go, oh, I know these two are equal. I know these two are supplementary, and set up your equations. If this is worth 4 points, your equations are worth like 3 points. The algebra is worth that additional point. Okay? So if you get bogged down in the algebra, just take a step back and go, what geometry concept are we covering here?